Okay, so it is a Common Core, and it says it's the functions trig it says basically the unit. Write this down. So we're doing unit circle in the coordinate plane. Coordinate plane is an extension of trig functions with radians. Is an extension of trig functions, which is what we're doing, trig functions with radians. Now we haven't done radians a whole lot because we did dumb degrees, but we're going to switch to radians right now. Okay, so write that down. Okay, now find all 6 trig ratios for pi thirds. And we learned in our reading these are our 6 trig functions, or trig ratios. Y over r. R is 1 on the unit circle. X over r, y over x, and then the cosecant ry, r over x, and x over y. So we're going to do this. We're going to all 6. So first of all, let's figure out what our terminal point is. So our terminal point, before we do anything, for pi thirds, right? So let's see, if I look at pi thirds, here it is. Here it is. And my terminal point is 1/2 square root of 3 over 2. So I'm going to write that down. I'm going to need that. So my terminal point is 1/2 square root of 3 over 2. Okay. Now, every point has an x and a y value, right? So in this case, my x value is 1/2. My y value is a square root of 3 over 2. And my radius on the unit circle is 1, okay? So, here's how we do this. It's actually pretty easy. So first, let's do the sine of pi thirds. Pi thirds, okay? That's my angle. Doesn't look like an angle, but it is. Pi thirds is my angle. It would be equivalent to a 60-degree angle, but we don't do dumb degrees, okay? So, sine is just the y value of my point. Square root of 3 over 2. That's the answer. You will not get this answer on your calculator. You'll get a decimal, and I'll mark it wrong.
Can you go math?
If you have a real fancy calculator, you can, but you have to have a really good calculator to get that answer, okay? Like you have to have a TI 92 or something of equivalence. Okay. How about cosine of pi thirds? Well, cosine of pi thirds, cosine is the x value. So it's 1/2, that's all. Tangent of pi thirds, well, tangent is the y over the x. It's the y over the x, so it's going to be the square root of 3 over 2 over 1/2. I'm going to have to do a little fraction work here, huh? So I'm going to do that on the side, okay? I like fractions. So what is the square root of 3 over 2 divided by 1/2? Well, I know how to do fractions, right? I'm pretty good at it. I'm going to invert and multiply. So that's the same thing as square root of 3 over 2 times 2 over 1. How's my fraction work? All I'm doing is trying to simplify this. Cancel, cancel, and I just get the square root of 3. That is the tangent of pi thirds is square root of 3. All right, now the sine of pi thirds was square root of 3 over 2, so its cofunction is called cosecant. So cosecant of pi thirds, let's see, cosecant is going to be 1, because that's the radius, over the square root of 3 over 2. I'm going to have to do a little fraction work on this one too. Oh, we learned a long time ago that if you have 1 over any fraction, it flips the fraction, right? Just makes it b over a. All right, remember that little trick? 1 over any fraction just inverts, flips fraction. So over here, this answer is going to be 2 over the square root of 3. And if we rationalize this answer, can't have a square root in the denominator. If we rationalize, we get 2 square roots of 3 over 3. That's the cosecant value of pi thirds. All right, so cosine has a cofunction. Its cofunction is secant. So if we go secant of pi thirds, let's see. That's going to be 1 over the cosine value, or 1 over the x value, right? So it's going to be 1 over a 1/2. I'm going to flip that. 1 over 1/2, same thing as 2 over 1, or 2. I don't need to rationalize that because there's no square root, so I just flipped it 2 over 1. Oh, you can put the 1 there if you want to, but 2 is good enough, right? I just flip my fraction, right? 1 over a fraction just flips it over, okay? And finally, tangent of pi thirds. Its cofunction is going to be cotangent of pi thirds. Okay, so now it's going to be the x over the y. So it's going to be my 1/2 divided by square root of 3 over 2. All right, well, that's kind of a mess. I'm going to have to do some fraction work here. I don't mind doing fraction work here, so let's see a little side work here. What is 1/2 divided by square root of 3 over 2, right? Invert and multiply the second fraction, so I'm going to go 1/2 times 2 over the square root of 3, right? Cancel, cancel. I get 1 over the square root of 3. Am I going too fast?
No.
But that's not a very good answer. Yeah, you can't have a square at the bottom, and Colby's right. It's just the square root of 3 over 3, okay? So here's my 6 trig ratios for pi thirds, okay? Okay, now what about pi halves? Let's do pi halves, okay? Pi halves is going to have a couple that are going to be undefined. We're going to go through that and see why, okay? So the same thing, okay? So we're going to do sine of pi halves, right? So first of all, let's get my terminal point. My terminal point is going to be the point at pi halves, 0, 1, okay? That's my terminal point, pi halves, 0, 1, okay? That's my x value, that's my y value, right? So my x value is 0, my y value is 1, and my radius, of course, is 1, because it's the unit circle. Right? So sine is the y value, right? So the y value is 1. Let's do cosine of pi halves. Cosine is the x value of the point, so the answer is 0. Tangent of pi halves is equal to the y over the x. The y over the x, 1 over 0. That's bad. That's very, very bad. So what's this answer going to be? Undefined. Undefined. Very good. Undefined is correct. Okay? So now, let's do the cofunction of sine. The cofunction of sine is going to be cosecant. So let's do cosecant of pi halves. Well, cosecant is defined as 1 over the y value, okay? So it's 1 over the y value. And the y value is 1. Okay, so 1 over 1, we just get 1. Cosine of pi halves is 0, but its cofunction is going to be secant. So secant of pi halves, let's see what that does. So it's going to be 1 over 0, because it's 1 over the x value, and the x value is 0. But 1 over 0, that's bad news also. So what's that? Undefined. And finally, tangent. Cotangent, my bad. Cotangent of pi halves, because that's the cofunction of tangent. And cotangent is going to be the x over the y. Okay, and the x value is 0 and the y is 1. We get 0 over 1, which is just 0. So here are the 6 trig ratios for pi halves. Okay, now let's do this. Now, example 3, we are going to do trigonometry without a calculator, because all we're going to do is just get it from the circle, okay? All right, so go to 2 pi thirds. Let's see, 2 pi thirds. 2 pi thirds is right. Let's see, where's 2 pi thirds? 2 pi thirds is right there, okay? You guys got it? 2 pi thirds is right there. And we want the cosine, which is the x. The answer is negative 1/2. Okay? Negative pi thirds is here. Think about a rotation. If this is positive pi thirds, if this is positive pi thirds, the negative pi thirds is here. Okay, with me on that? So we're right there, and if we want the tangent is going to be the y over the x. So it's going to be the negative square root of 3 over 2 over my 1/2. We kind of did all that work. We did all that fraction work for this one. We did it way up here, right? Didn't we do it way up here, right? Did all that work up here. We got square root of 3, but in this case it's just going to be a negative square root of 3. You okay with that? We already did the invert and multiply and divide and cancel. Okay. Okay, sine of 19 pi 4. So 19 fourths is not on my circle, but 4 goes into 19 how many times?
4.
And how many left over?
3.
Okay.
We can't see.
Okay, thank you. So let's take a journey. Okay, let's take a journey. We're going to go 2, 4. You okay with that? 2, 4, right? And 3/4 puts me right there. And if I'm looking for the sine of it, it's the y value. Square root of 2 over 2, okay? Square root of 2 over 2. All right, secant of 2 pi thirds. So secant is 1 over the x value, okay? Secant is 1 over the x value. Let's find 2 pi thirds. 2 pi thirds is here. The x value is negative 1/2. So it's just going to be 1 over negative 1/2. We kind of already did that work way over here, right? We did that work right over here. So we're just going to make that, flip it up to a negative 2, okay? Cosecant. Now cosecant's 1 over the y value, okay? So let's find 5 pi fourths. 5 pi fourths is here, okay? And I want the y value. So the y value is negative square root of 2 over 2. So it becomes 1 over negative square root of 2 over 2. We're going to flip the fraction, right? We're going to flip the fraction, so we're really going to get 2 over negative square root of 2. If we rationalize that, we get 2 square root of 2 over negative 2. If I rationalize that, cancel the 2's, and we just get an answer of negative square root of 2. Cotangent, negative pi 6. Okay, cotangent is the x over the y, all right? So cotangent, negative pi 6 is here. Okay, negative pi 6 is right there. Because that's positive pi 6, so we rotate to the negative pi 6. And cotangent is the x over the y, so we're going to go square root of 3 over 2 over negative 1/2. So we're going to get a square root of 3 over 2 all over negative 1/2. And we have already done all that math over here, didn't we, right? And we wound up with a square root of 3, but in this case we're going to get a negative square root of 3. Okay, not too bad. Now, keep in mind that, sure, you could do some of these on your calculator, but the problem is that I'm going to want this answer. I'm going to want the square root answer. I want the square root answer, okay? So if you rely on your calculator, I will mark it wrong, okay? All right, now you can use your calculator. And let's talk about mode. Okay, let's talk about mode. So first of all, mode. The only time, listen carefully, the only time you need to worry about mode is when you push sine, cosine, or tangent. That is the only time, because sine, cosine, and tangent deal with angles. Okay, one more time. Sine, cosine, tangent deal with angles, right? Now we have dumb angles called degrees, and we've got smart angles called radians, right? Sine of 2. That's a radian. How do I know that's a radian? There's no little degree symbol, right? It's about here somewhere. It's right around 120 degrees, because you go about 1, 57, 2. Okay, it's right around here somewhere. So we want the sine value of that. Well, we're going to use our calculator. So how do you use your calculator? First of all, go to your mode button. So where's your mode? Right there. M-O-D-E, mode. Okay. I'm in degree. I'm going to shift myself into radians, okay? So I'm in radians. Awesome. Quit. Now I can do sine of 2. What's my answer? About 0.909. I'm in radians, yeah. About 0.909. Actually makes complete sense to me. I'm going to show you why. Equals about a 0.909. Now, if sine is the y value, I want you to know why, because you know me. Sine is a y value, right? So think about this. You ready? I'm right about here. The length from here to here is 1. Agree? The length from here to here is 1. Correct? So at about this angle here, the length's a little less than 1, the height's a little less than 1. It's about 0.909. All right. Now secant at 1.2. I don't have a secant button on my calculator, but I do know that secant is 1 over cosine. Okay. I know secant is the cofunction of cosine, and I can do that on my calculator. Okay, clear. I can go 1 divided by cosine of 1.2 in radian mode, and I get about a 2.76 approximately. 2.76. Okay. Okay, almost done. Okay, example 5. Here's the problem with example 5 is I get 3/5. This is not on the unit circle. This is not on unit circle because the radius in this case is 5. The radius is 5. Because cosine is x over r, isn't it? So here's what I know. Cosine of any angle is equal to the x over the r value. So here's what I know. The r is 5 and the x is 3, right? So what I want to do anytime I do these is I always want to draw a triangle, okay? Because it's not on the unit circle, so I'm going to draw a triangle, okay? So let's see if I can draw a triangle, and it's going to be in quadrant 4, right? So I'm just going to try and draw a little triangle over here in quadrant 4. My quadrants go 1, 2, 3, and 4, okay? Now when I draw these triangles, they have to be flush with the x-axis, okay? So I'm just going to draw a triangle, a right triangle. It doesn't have to be perfect, but it's got to be a right angle, okay? Here's my angle theta, okay? Here's what I know. This is 5, and this is 3. I know that because the radius is 5, and the x value is 3. There you go. So Colby's saying this side is 4. She's absolutely right, but Colby, I'm going to say it's -4. Yeah. Does that make sense why this would be -4?
Yeah.
Okay, -4. Now, if you guys don't know what a 3, 4, 5 triangle, Colby just did in her head. She did Pythagoras' theorem. She did x squared plus y squared equals r squared. That's Pythagoras' theorem, right? You'd have your 3 squared plus your y squared equals 5 squared. And then you end up with y equals plus or minus 4. Now, it has to be -4 because we're going down, correct?
Mm-hmm.
We're going down, so it has to be negative. So here's what we know. I'm going to put y equals -4 here, okay? And I'm going to highlight all of these. We are almost done, really, okay? Boom, boom, okay? So let's see what we got. So if I take a look at this, let's do our other 5 trig. So I already know what cosine is, so let's figure out what's the sine of this angle. So sine is equal to the y over the r, right? So it's just going to be as easy as this. -4 over 5 is the answer. -4 over 5. Because it's the y over the r. Y is -4 and the radius is 5. We've done cosine, so let's do tangent. Tangent of the angle is going to be the y over the x, right? Okay, my y is -4 and my x is 3. -4/3. My cosecant of theta is the r over the y, or the reciprocal of sine, right? Or the reciprocal of sine, so it's just going to be 5 over -4. My secant, secant of theta is going to be the r over the x, or it's the reciprocal of the cosine. Cosine's 3/5, so secant's going to be 5/3. Okay? And finally, cotangent of my angle is going to be my x over my y. It's also the reciprocal of tangent, so instead of -4/3, we're going to make it be 3 over -4. How's that? Not too bad, is it? it all comes back to regular right triangle trig too. Okay, let me push stop.